afternoon. My name is Selim Pulcu. I'm a projects and training expert at Marmara Municipalities Union. I also work in the Data and Technology Center at MMU, and I'm also one of the organizers of MARUF. And as you know, AI and artificial intelligence from Naue has become super popular in the past year with the introduction of GPT and image generation models such as Midjourney, DALL-E, and how easy and accessible they are. And I'm sure one of you and probably are still currently using ChatGPT, for example, in their daily lives and what they need. And in fact, in preparing MARUF, we benefited from GPT a lot. In writing emails, streamlining texts, and session contents, and so on and so forth. And we'll probably be still benefiting from it in our reports, because after every MARUF we publish a very lengthy report, and using a speech-to-text model to transcribe an entire session is pretty helpful in writing a lengthy report. But there is more to AI than just using GPT and this and that. And according to and based on a report published by United Nations Habitat and Mila Institute for AI, and the title is AI and Cities: Risks, Applications, and Governance. These technologies can support municipalities in various ways, such as governance, energy management, and urban planning especially. And today we are joined by Dr. Sophie Naue from UNITAC, and she will demonstrate one such application of an AI technologies in urban planning. And Dr. Sophie Naue is an urban planner with a focus on international projects and digital transformation. She currently works as the academic lead for the United Nations Innovation Technology Accelerator for Cities, UNITAC in short, which is formed in collaboration with UN Habitat, United Nations Office for Information and Communication Technology, and City Science Lab, which is a part of the HafenCity University in Hamburg. And she will present the BEAM model, which is a deep learning AI model for mapping out settlements. So it uses satellite imagery. You upload, you use the satellite images of a settlement, and it maps out, where the settlements are, where are the houses, roads, etc., etc. So it carves out the entire layout of a settlement. And mapping out is especially crucial for informal settlements, and as they're the most vulnerable, they're comprised of the most vulnerable segments of the society. And because of their informal nature, there's often a lack of data and basically lack of knowledge on how to provide the needs, that are especially important for such settlements to address to. So, the model was used in collaboration with eThekwini municipality in South Africa, which has a very large, informal settlement. And proper mapping out was conducted to provide even the very basic needs the residents of these areas need. So without further ado, I present you Dr. Sophie Naue, and the floor is yours.
Yeah, thank you very much for this invitation, first of all, and for this kind introduction. A few words about myself. For my background, I'm an urban planner. As you mentioned, I'm working currently for UNITAC. I have several years experience in working in developing projects in the international field, and with UNITAC. UNITAC is the United Nations Innovation Accelerator for Cities. We developed a pilot project focusing on AI. But before I go into detail into this project, I would like to say a few words about UNITAC and this special collaboration and our lab in Hamburg at the City Science Lab. So UNITAC is a partnership among UN Habitat, the Office for OICT in New York, and the HafenCity University. We are based in Hamburg at the HafenCity University, and we are part of the People-Centered Smart City flagship program from UN Habitat. And what we do is actually we support national and local governments in their digital transition. We work with data and cities, and we have a diverse team of programmers, city planners, to create open, transparent, and participatory digital governance approaches. on one hand, to reduce the digital divide. We use a lot of different mapping, spatial analysis, data visualization to support evidence-based planning processes. And what we do is we develop tools. And when I talk about tools and digital tools, I talk about digital applications, systems, and to use data and actually in an innovative day. And I think the last point on this slide I already mentioned, that for UNITAC we support smart cities which are people-centered, so we support a need-driven approach in cities. I would like to share a few images from our lab in Hamburg so that you can have an idea of our ecosystem and our lab culture. So we work in a multidisciplinary team where we have programmers, data scientists, economists, communication experts, and our research and action field is the digital city. We believe actually in an agile development of digital tool development. We follow a multi-stakeholder approach, and we have an open and experimental space, as you can see on these pictures, where we have all those touch tables where we develop applications. We develop, on one hand, prototypes, but as well applications beyond prototyping. This is important. And here, together with our sister lab, the City Science Lab in Hamburg, you can see just a variety of tools that we do develop. City Science Lab is part of the MIT Media Lab, and the City Science Lab network. So we do develop data platforms, interactive mapping, AI-based tools. That's the one that I'm going to present in a few minutes here in a bit more detail. We as well focus on digital citizens participation tools, on scenario planning tools to better plan cities, doing reachability analysis. We develop data storytelling tools as well when we are in contexts where we have a lack of data and we have to create data together with citizens, what happens a lot in developing projects. We co-design the city due to virtual and augmented reality. And last but not least, we develop digital twin technologies. This just to give you a short introduction on our work. And now I would like to focus on a pilot project that we developed together with UNITAC, or with UNITAC and the City Science Lab, together with the city of eThekwini in South Africa. eThekwini is Durban in South Africa, where we use artificial intelligence to map informal settlements. And actually, you can already see the results on this first slide. This is a tool that uses machine learning to accelerate the mapping of informal settlements based on aerial images, and that maps out rooftops. The idea here was to develop an innovative and scalable approach to accelerate mapping processes and to automate mapping processes. Just to provide you with a little bit of background information, we have informal settlement growth all around the globe. Here in eThekwini, we have more than 25% of its population living in informal settlements. And in order to be able to develop a pipeline of upgrading measures and to have all data that is necessary to develop those pipelines, we need to keep track of this urban growth and know where are settlements densifying and growing. So there are a few challenges of mapping informal settlements. So the first one is that mapping informal settlements is very time-consuming. So it's when you do it manually, it's actually a work that has to be done with a huge team. And in eThekwini, we had the case that we had only 15 on-the-ground land monitors who kept track of the urban growth. So this manual mapping process was very time-consuming, and you cannot keep track of these fast changes in the urban environment. So that leads to often outdated records. Settlements makes it difficult to plan upgrading measures in an appropriated way. So this was one of the objectives why we start using AI to, on one hand, accelerate detection of informal settlements through aerial images and AI, to keep track of density changes and produce up-to-date records and maps of informal settlements. Here you can already see a few of our training images because you have to label data and work with this data. So going a little bit deeper into the BEAM tool. BEAM is the Building and Establishment Automated Mapper. It's a tool that we developed, or it's an application that we developed to solve this challenge, and it's a deep learning tool. I will skip this slide and just go directly into our tool development. So the idea here was to develop a user-friendly tool which be easy to use for the municipality to keep track of density changes. So actually, by simply uploading images to the certain model, you can map informal settlements. So you have here 4 steps. On one hand, you select an input folder where your aerial images are stored. You select the model, and in a third step, you run the building detection, and then you got an output which looks like this. This is QGIS, where all informal settlements are marked. So this is actually the result that you get out of this tool. So what the tool does, it marks all pixels in an aerial photography, and it produces up-to-date GIS layers where informal structures are marked. And it does this quite fast. I will come to this. This is a good thing about AI and of using AI. To get there, we had to face a few training challenges. I mentioned this. We had to label all the data, mark all the rooftops to get a high accuracy. And in this training process, we had in the beginning a lower accuracy because on the edges, accuracy of buildings, the accuracy was sometimes lower. Model marked overlapping structures, and in informal settlements you have a lot of overlapping structures at once. Sometimes buses get picked up as buildings because they have the same size as a building. Buildings in the shade of trees doesn't get picked up. And then we trained the model with our data scientists, and today we have an accuracy of 94%, which is quite high, and good resolution. So I can say that as an outcome and achievement, we could automate and accelerate mapping processes, at least for the city of Itiquini, and make workflows here more efficient. We can map the whole city. It's a city of 3 million in 72 hours. That means 1 image in 70 to 90 seconds. To manage expectations, this model until now is only trained for the city of Itiquini, but I think we will get into this discussion as well a little bit later. And it needs to be trained in order to get this high accuracy as we had in Itiquini. In our use case, or in our first pilot project in Itiquini, it was super important for us to focus as well on knowledge transfer and skills transfer. So we co-designed the project together with our project partners, the Human Settlement Unit and the Corporate GIS. We developed step-by-step guidance, a user manual on how to train, how to install the model, how to use the model, and as well on how to train it further, because the idea is to train the model further with new images from the next years. Then training is much easier, and so we had been in a constantly feedback loop with the city of Itiquini to improve the model, and we are now with this project in a second phase where we tried to provide better accuracy as well for not informal settlements, CBD area, industrial areas. And these are a few technical requirements to run the tool on a local machine. I will not go into detail. Just ending with this presentation, I would like to say a few words about what we have in mind to upscale. This tool is currently trained on aerial images. Upscaling it, we are training it on satellite images because it's most of the time it's a bottleneck that you don't get aerial images in a high resolution to use the model. So we're planning to do an inventory of informal settlements in Central America, mapping all or 8 Central American cities using this BEAM application, training it further on satellite images, training it further as well in different towns in Namibia on drone imagery. So this is what we have right now as plans with this tool. And there are a few ideas as well to combine the tool with census data, to combine the tool with community mapping, with bottom-up data from communities, and explore further use cases, because informal settlement growth is all around the globe. If we look to the Marmara region, which is growing, so this might be as well an interesting tool for different other settings. And yeah, last but not least, I would like to say a few words about AI, because AI is especially useful in the context where we have limited data. Or an absence of collecting data strategies. So AI has a potential here to automate and accelerate those mapping processes to have a huge impact, but we have to be aware, or we have to ensure that we transfer knowledge and skills so that as well municipalities can use this data. And we have to involve civil society in data governance because data makes certain stories visible. Mapping a community makes a community visible. And if we do so, we have enormous benefits for planning, but we need to ensure as well that we stick to data protection of human rights, to respect those. This is on the slide. You can just see that for further information, you can scan the QR code and get to the story of this tool. And I think I have a next, no, sorry, I don't have this slide about the report that you mentioned, the AI and cities report that UN Habitat developed on AI, which is really nice as well to go into detail more. Yeah. For now, thank you, and I think we get into discussion now.
Yeah, if our audience has any questions, you can either use the MARUF app and address your questions, and I can read them here, or we can do it in an old-fashioned way and just use a microphone. And one of our speakers for the next session, artificial intelligence, hype or not, wants to ask a question, and it might be interesting to begin with him. I have a few of my own, but let's see what he has to say.
So, dear Sophie, thank you for your presentation. It was very interesting. One of my PhD students is working on informal urbanism. So, actually mapping informal settlements can as well be very disempowering, because those people are somehow in deep poverty or deep states. So also with AI, it's projected there will be job losses as well at different levels. So what kind of responsible, ethical AI precautions have you taken to not to disempower these people, because in the future they may lose their jobs, and are you going to take their houses as well? So thank you.
Yeah, thank you for this question, because we have been talking in Itiquini a lot about that, no? Because mapping informal settlements makes those settlements visible. In the case of Itiquini, it was a need-driven approach from the Human Settlement Department. So on behalf of UN Habitat, we signed an MOU, a letter of intent as well, that this data is not going to be used for worst-case eviction of informal settlements. So, but it is a case that can happen. So it's super important to take prevention and to sign those MOUs that this data is just used to provide, in this case of Itiquini, public services, upgrading measures like water, electricity, social infrastructure, and those things. What we started to do last year when we had our first handover of the tool was to start with an advisory meeting, inviting not only representatives from the municipalities, inviting as well community representatives. So you have SDI, Czech Dwellers International, but as well you have a lot of different community mapping organizations, social organizations. So We invited them all, we presented the tool, so that this is actually not a tool that can only be used by the municipality. For now it is, because the power of the machine that you need to run it is not available in an informal settlement right now, but to create awareness. And there the idea is to create a community of practice involving as well community representatives, and in the future start projects where we can involve community mapping, where communities especially can design what challenges they have, what needs they do have. So this is actually just a start to map an informal settlement, and then the use of the data needs to go beyond.
Any other questions from our participants? Let me also check the app, but yeah, let me see, there's a few. One question is, I'll translate it in English to my best of my capabilities. Can we detect damaged structures using this model? And can we do this? Can we detect a risk carrying such structures and infrastructures using this model to map out the damaged areas and the risk areas?
Very interesting and good question. Yes, we can. We need to train it further, but for example, this tool can be used in areas when we talk about damaged structures. I think you refer to earthquakes, for example. No, so you can provide quick before and after, so that you can see which structures get damaged during an earthquake. In Itiquini, we were confronted with floodings. So there, the main issue are floodings, high floodings in April, and so that this tool is going to be used by the municipality to detect in which areas informal settlements were affected by those floodings, where our informal settlements are as well constructed in risk areas, and for earthquakes, for different nature disasters. It's a tool that can be, and AI can be super useful and needs to be trained in for each case, but yes.
There's a more technical question on how to train it. What do you mean by machine learning, and what exactly do you mean by machine learning, and how the process goes? So it's more of a technical question, but if you'd like to answer.
Yeah, I'm not the one who programmed this tool. I'm more coordinating this project, but machine learning, deep learning means learning by repetition. So learning by repetition is that you mark which structures are informal so that the model can recognize those. As I mentioned when I showed these training challenges, so if the model then picks up, for example, buses, then you have to tell the model, okay, this is a bus, this is not a building, and then it can detect it. Accuracy 94% because it still makes errors. We're currently doing a proof of concept with this tool in the city of Cape Town, where we're using deep learning AI and combining this with LiDAR data, because we have really, really good accuracy as well when we use LiDAR data, and a combination of LiDAR data and machine learning, and we try to get higher resolution, because in Cape Town we are confronted with informal settlement growth in backyards, so you have really a lot of overlapping structures, and yeah. I hope this was sufficient technical-wise.
Thank you for the brief question. I also wanted to have a few questions of my own. Is Beam model free to use? I mean, we have lots of municipality representatives from here. Can they download and install and train their, train for it for their own purposes?
All tools, softwares, and applications that we do develop on behalf of UNITAC and the City Science Lab are open source. Yes, you can download those. You need to invest a little bit of training because, for example, with the Beam tool, when we were ready with it in Itiquini, we used it in the city of Dar es Salaam, and it has not the same accuracy because it depends on the angle images are taken, on the light, on a few technical circumstances, so you need to train it, but we provide municipalities with notebooks on how to train it. and how to develop it further. And an idea of UNITAC is as well to do capacity building, so that we are not going to program and train the tool for each city, so that we do technical capacity building, training GIS persons, representatives in different municipalities, how to use the tool and how to apply it. It still requires a bit of effort to be able to map a city in 72 hours like an eTqueenie. So it needs to be trained, and yeah, but this is something that we are super interested in doing.
But in either case, it's still, I'm sure, a better way of mapping out an entire city just instead of hand by hand. The preparation process, I'm sure, takes a lot of less time to map out the entire city. I also had another question regarding using AI technologies have their own issues, especially in the matters of accountability and governance and transparency. For example, a certain AI model does something wrong, and who are we to blame? Like who would be blamed for? But I think you addressed my question by how you included all the stakeholders, the people signing an MOU, and this will not be used for eviction. So yeah. It was like I already had my answer, but thank you for that.
Yeah, but I can add one thing on that, because ground truthing is super important. It's very, very important, no? Because we have an AI model, this maps, and then then we have, for example, 10 buses get picked up as houses. So ground truthing is highly important for the training process and afterwards as well. I had a master's student from UCL in London who did that the last half a year, and for this tool it gets better and better. So, but this was super important to get back to the municipality in eTqueenie to get older satellite images to compare, and this is actually a manual work that needs time, and then you can say, okay, now I have developed a tool that is actually ready to accelerate processes.
All right, thank you. Unfortunately, we're out of time for this session.